My name is Kennedy Stern, and I will be going through the steps of how to complete a word problem using Newton's law of cooling. The situation is just before 6 p.m., students enter the classroom to find the best professor ever dead of an apparent homicide. At 6 p.m., the temperature of the body was 80 degrees Fahrenheit, while at 7 p.m., it was 75 degrees Fahrenheit. If the room is kept at a constant temperature of 70 degrees Fahrenheit, what is the time of death? The equation for Newton's law of cooling is as follows. T is equal to T ambient plus parenthesis T object minus T ambient close parentheses times E to the power of negative K times T. Capital T is equal to temp. T ambient is equal to temperature of room. T object is equal to temperature of the object at some given time. K is equal to the decay coefficient, and lowercase t is equal to time. I like to point out the known in problems. And what is known is at 6 p.m., the body is 80 degrees, 7 p.m., the body is 75 degrees, and the room has a constant temperature of 70 degrees. And I add in the average body temperature of a human is 98.6 because I'm going to use that eventually. The first step of this three-part problem is to determine what K is, which is the decay coefficient. And once we receive this number, we will be able to use this to determine the time elapsed between the death and the discovery of the body. So to find K, you have 75 is equal to 70 plus parenthesis 80 minus 70 close parenthesis E to the power of negative K times 60. I have 60 for time because 6 to 7 is 1 hour, which is 60 minutes. And like once I receive the number for the actual time elapsed, I could just easily convert that. To start off, you subtract 70 from both sides, and you do what is in the parenthesis, which will give you 5 is equal to 10 times e to the power of negative k times 60. You want to subtract 10 from both sides, so you can have e on one side and the other numbers on the other side, which will give you 1/2 is equal to e to the power of negative k times 60. To get e out of the equation completely, you will take the natural log of both sides, because when you do that, it cancels out e, or it has an equivalent to the number 1. So you have the natural log of 1/2 is equal to negative k times 60. Now you want to get k by itself, so you divide both sides by 60, which will give you negative k is equal to the natural log of 1/2 divided by 60. Once you put that in the calculator, you will have negative k is equal to negative 0.011552453. Since both sides are negative, divide by negative 1. You can get, I rounded the numbers, k is equal to 0.0116. Now, to solve for B, which is determining the time elapsed from the time of death to the time of discovery, I will use the k that I got in point A, and I will also use the 98.6 that I know already. And then a few of the numbers will be switched around. So you have 80 is equal to 70 plus parenthesis 98.6 minus 70 close parenthesis time e to the power of negative 0.0116 times t. Like in the last problem, you subtract 70 from both sides, and you do what is in the parenthesis, which will give you 10 is equal to 28.6 times e to the power of negative 0.0116 times t. Again, you will subtract to get e semi alone by itself, which will give you 10 over 28.6 is equal to e to the power of negative 0.0116 times t. Again, you take the natural log of both sides to get rid of the e in total, which will give you natural log of 10 divided by 28.6 is equal to negative 0.0116 times t. You want to get t by itself, so you divide both sides of the equation by negative 0.0116, and t will be equal to 90.5880711, which I rounded off to 90.6, which is equivalent to 1 hour and 31 minutes, because I have this as minutes and seconds, which, not minutes and seconds, hour and then minute. 90 minutes is an hour and a half, and 60 seconds is 1 minute, so altogether that is an hour and 31 minutes. And now to C, where you determine the approximate time of death. The body was discovered at 6 p.m. The elapsed time between the death and the discovery of the body is an hour and 31 minutes. So subtract the hour, which will have you at 5. And then once you get to 5 o'clock, you can just subtract 31 minutes, which will have you at 4:29. So the approximate time of death is 4:29 p.m. Hope this helps.